Okay, let's look at DSMA 8, excuse me, inequalities. We've got less than sign. So a less than sign points to the left. We have a greater than sign that points to the right. We have less than or equal to. The line underneath lets us know that it's or equal to, and we have greater than or equal to. Usually we have equal to, and then of course not equal to. So we're going to be looking at these on the number line, and that'll make more sense of which direction we're going. So number lines are critical in statistics. As we get to the other chapters, we're going to be drawing number lines all the time. We've got to make sure that we know which direction we're going, and then we also are going to have to look at those tick marks. So this one asks us to label the number line around 11 to 12, counting by 0.25. What that means is each tick mark is going to be 0.25, 1/4. We are always going to start with the smallest number and work up to the largest number. So we will always want 11, in this case, 11 to be on the left-hand side, 12 to be on the right-hand side. So that narrows us down. And then we're going to be jumping by 0.25. So we're going to start with 11, then we're going to add 0.25 for the next tick mark, add another 0.25 for the next, and so on until we get up to 12. And so we can see that it would have to be C. The problem with A is this is going backwards. It started with 12 and went down to 11. We do not want that. B is the same way, plus the tick marks were wrong. They were jumping by 0.5. D was in the correct order as far as 11 being first, but notice they jumped by 0.5 for each tick mark. So that's not going to work. Therefore, the answer is C. All right, so this is just another number line for you to see. The first one, each tick mark is jumping by 0.1 or 1/10. The next one is the 0.25, which is 1/4, like we just did. The last one is 0.2, which is jumping by 1/5 each time. All right, let's look at inequalities. So this first one, we have x less than or equal to 11. This means that we want all of the numbers. We're using a number line to denote that we want all the fractions, all the decimals, every single number that is less than 11 and also that is equal to 11. So it's a large solution set. Notice that the arrow on the number line is the same direction as the inequality. That is a good check for us. And then when we are at the tick mark that's 11, we have a closed in dot. So what's going to happen for us is if we have a less than or equal to or greater than or equal to, we're going to have a closed in dot. Sometimes we also use square brackets. We'll see as we get to the problems. If you have a less than or greater than, then you're going to have an open circle on the number line. We also use parentheses. Okay, that just denotes that we're not including the actual number. So on the first one, we are including 11. So our solution set is 11, and then every single number less than 11. Doesn't matter if it's a decimal, a fraction, or an integer, which is the numbers on our tick marks. Now on the second one, we have x greater than 11. So notice my arrow points in the same direction as my inequality, but this time I have an open circle. That's because the 11 doesn't count. It's not included. We're going to take the very next decimal right after 11, but we are not going to use 11. All right, so here's some more examples for you to look. Again, you can see that the arrow on the number line points the same direction as the inequality. If I have a less than or a greater than, I'm going to use an open circle. That denotes that I'm not including the actual number where the open circle is, but I'm using the very next decimal or fraction after that. The less than or equal to or greater than or equal to, we have a closed in circle, and that's because we do include that number. Sometimes you'll see that word inclusive. That's what that means. Now, in those examples we've looked at so far, there was an arrow pointing one direction or another. And so that means that we had a very large solution set. Sometimes we have endpoints, right? So this first one is -2 is less than x is less than or equal to 1. So we're going to start at -2, but it's going to have an open circle because it's a less than sign. So we're not really starting at -2. We're starting just past it, like a little smidgen past that very next decimal is where we're going to start. We're going to have a solution set of everything in between here until I get to 1. I'm going to actually include 1 because it's a less than or equal to sign. But what that's showing me is that I have the 2 ends for this solution set. It doesn't go on forever. Now the next one has 2 less than signs. So I'm going to start at 2 with an open circle because I'm not including 2, but I'm starting right after the 2. And then I'm going to use all of the answers up to, but not including 4. So I'll use the decimal right before 4, but I'm not going to actually use 4. And we use this notation because it'd be really hard to write 3.99999. So instead we use 4 and say that it's not inclusive, or we use a less than sign. Okay, so let's take a look at this. We have a variable w, and it's going to be between 0 and 6. We have a less than sign, not less than or equal to. So remember I talked about if we have a less than sign or a greater than sign, some number lines are going to have an open circle. Sometimes we're going to use parentheses, and that's how we're going to use if they ask you for interval notation as well. So this one is going to start just past 0. I'm going to use a parenthesis at 0. I'm going to start just past 0, go all the way up to, but not including 6. So right before the 6. So it looks like it's going to be D. It's a little confusing. They put parentheses and brackets, but just look carefully. All right, this one's also going to be parentheses because it's less than. We're going to use parentheses. We're going to start at -5.5. And we're going to end at -3.5. Looks like it's C. Oh, this is A, C, B, D. That's because when I cut and paste, sometimes that happens. It's not that I don't know my alphabet. Okay, so I'm going to use parentheses because it's a less than sign. If it were less than or equal to, I would use a bracket. Okay, so we haven't really worked with moving things around with equations or inequalities, but let me just show you how this works with the double inequality. So we want the variable in the middle all by itself. Okay, this one has x plus 4 in the middle. We don't want that plus 4. We just want the x. So we're going to go ahead and subtract 4 because that would give me 0, right? 4 minus 4. But the problem is I also have to take care of both of the ends. If I subtract something in the middle, I have to also subtract subtract 4 from the right-hand side and from the left-hand side. We have to keep the inequality completely balanced. So that means I'm going to have a -6 on that end, less than or equal to x. That's what I wanted, x all by itself, less than or equal to 6. And that's what they want me to go ahead and put into this problem. They just want to see that you're able to put it back into what's called its basic form. Okay, so again, this doesn't look pretty because it has decimals, but that's okay. We still have a compound inequality, or a double inequality it's called. So we have a less than or equal to sign in 2 places, but we want just x in the middle. What we're going to do, it is x minus 0.1. We need to do the opposite, right? Since that is minus 0.1, we need to add 0.1. That would give me 0 and just have x by itself. But if I do that, I have to do that on both sides. right? I have to add the 0.1 all the way across. So on this side, I would have negative 0.13. If decimals drive you crazy, just pop that right into the calculator. With decimals, we want to line them up, but these are opposite signs, so you have to be really careful. Less than or equal to x, less than or equal to 0.33. This is actually my answer. This is the inequality now in basic form. It's in basic form because I have x all by itself in the middle of the double inequality.